Well, good morning, everybody. Welcome to NASA's Johnson Space Center for our series of briefings on the final flight of Space Shuttle Endeavour to the International Space Station, STS-134, Utilization Logistics Flight 6. The first briefing today is a program overview, and then we'll have another series of briefings to outline the mission leading up to the Crew News Conference this afternoon. So we'll start with the program overview. Joining us is John Shannon. He is the Space Shuttle Program Manager, and also joining us is Kirk Shireman. He is the Deputy Manager for the International Space Station Program. Of course, we'll hear from both gentlemen, and then we'll take questions here and at other NASA centers. So with that, we'll get started, and I'll turn it over to John.
Okay, thank you, Kyle. It's good to be here again. I haven't talked to most of you since the outstanding 133 mission earlier this month, where we completed the ISS and accomplished more than 100% of our mission objectives. So that was an outstanding set of work by the entire team, and we're just kind of rolling along here to finish out the program strong, like I asked the team to do. Processing is going very well for STS-134. Of course, Endeavour is out at the pad, all stacked up. We've had an extremely smooth flow with the vehicle. The payload arrived at the pad on Monday. We opened up the payload bay doors yesterday, took all of our optical measurements. That's going through the normal processing today, and we anticipate installing the payload tomorrow. And everything is looking extremely good for an April 19th launch. That's all I have.
Kirk.
All right, good morning. It's a pleasure to be here talking to you about the International Space Station and this upcoming shuttle flight, ULF-6 STS-134. As you know, we're going to launch the AMS, Alpha Magnetic Spectrometer. It's a large external payload for the ISS, and we're very much looking forward to having it on board. Weighs about 15,300 pounds, so a significant payload to add to the ISS. We're also launching an external logistics carrier, ELC number 3, which has a number of spares on it. But I also wanted to mention that it has two additional external payloads. It has STP-H3, which is a set of experiments looking at plasma, digital imaging of stars to support future attitude determination systems, heat transfer. It also has a MISSI-PEC, which is a materials on ISS experiment looking at exposure of materials to the space environment. This is MISSI-PEC number 8, and of course we'll return MISSI-PEC number 7 on this flight as well. The last thing, of course, we're going to transfer the orbiter boom assembly to ISS. If you remember, we used that boom on in October of 2007 on STS-120 Flight 10A to repair one of our torn solar arrays. So we're looking forward to having that contingency capability on board ISS. All in all, we're launching up internal pressurized. We're launching up about 175 kilograms of payloads. We're returning 271 kilograms of payload samples in the pressurized mid-deck of the shuttle. And we're launching 7,400 kilograms of external or unpressurized payloads. That's about 16,300 pounds. And we're returning 153 kilograms of unpressurized payloads. So you can see this is a big flight for ISS in terms of having its spares on orbit, and also primarily to launch some significant payload capability. This spring, actually the whole year has been a very busy year on ISS so far, and it'll continue all the way through the spring. First of all, we're very pleased to have the safe return of Scott Kelly and Kaleri and Skropochka last Wednesday on 24 Soyuz. That was a very big and important event for us, and we're very glad to have Scott back here in Houston. The HTV is going to undock on Monday the 28th, which is a big event. For a number of reasons, but one of the biggest is, of course, it marks a first step, anyway, in recovering Japan and their space capability. In fact, their space center, the SIPSI, started its 24-hour operations, resumed its 24-hour-a-day operations this past Monday. So they're stepping back up, and we're looking forward to the undock of HTV, or unberthing. In fact, our mission management team, the IMMT, is going to talk about that tomorrow and finally confirm the date for Monday. We have, of course, the 26 launch, the 26 Soyuz launch with Poroshenko, Gagarin, and Samokutiev. It's set for April 4th. You probably have heard April 5th, but it's really April 5th. In Kazakhstan, it's April 4th GMT, and so we tend to mark all our information in GMT, so that's why I'm talking April 4th. So we're looking forward to that. And of course, followed right after that, we have this mission. So lots of things going on, and we're very much looking forward to a busy spring on ISS. Two last things I'll mention that you've certainly heard of that we'll celebrate. We're going to celebrate the 50th anniversary of Gagarin, so the 50th anniversary of human spaceflight. That's a big event here on the ground, and we'll also have a few activities on board. And of course, at the same time, we're going to celebrate the 30th anniversary of the Space Shuttle program. The first flight of the Space Shuttle, and John was probably in high school, maybe when it started. So looking forward to that anniversary as well. Thanks very much.
Junior high.
I was wondering if he was going to answer that. Yeah, we'll just start over here and work around the room and start with Mark in the back.
Hey, thanks, Kyle. Mark Carreau for Aviation Week, and I have a question for John Shannon. Can you sort of review or preview for us what happens with the workforce going forward at this point?
Sure. As you know, we have been stepping down our workforce over the last really 3 years. Back in late 2006, the shuttle program had 14,000 contractors. We're currently down to just over 6,000 contractors. We had 1,800 civil servants that time. We're just over 1,000 civil servants right now. So when we were in the full production mode and in integration, we had about 16,000 teammates supporting shuttle operations, and now we're down to about a total of about 7,000 if you count civil servants and contractors together. That, as we finished different manufacturing processes, as different things were delivered to KSC, those personnel were let go. So it's been this gradual phase down. We're at a point now where it's primarily operations and sustaining engineering for the different elements that are left, and we require those out to the end of the program. There will be a layoff, or layoff is not exactly the right term because a lot of the employees are being placed within their contractor companies in other areas. That'll occur on the first 2 weeks of April, and we'll reduce the team by about 700, and that's spread across several different contractors here in a couple weeks. And then we'll retain the rest of the team. It's about 5,500 contractors until the end of the program, and at that point it'll be a significant layoff, and the rest of the contractors will either go to other jobs within their companies, or they'll be laid off, and civil servants will be reassigned to other tasks. So that's coming up in probably the late July timeframe. The shuttle program will transition at that time to what's called a Space Shuttle Program Transition Retirement Team will be headed by Dorothy Rasko, who's currently our business manager. And she'll have about 300 employees that will continue the process of dispositioning the assets of the program.
Thanks very much. And for Kirk Shireman, I wonder if you might step back to the earthquake and tsunami and sort of step through what happened with the control center in Japan and how they recovered. I'm sorry, I'm not asking you for the Encyclopedia Britannica, but just kind of how everybody came in to fill the gap, and whether that experience is offering a lesson learned or something to look at how the other control centers are protected if something like this were to happen in Europe or here.
Okay, that's a good question. So what happened, of course, they had the earthquake, which was an unplanned event. And right away they had difficulty with power in their command servers, and of course the people themselves were quite shaken up. So it turns out that there's capability to send all the commands for the Japanese segment and for the HTV here in Houston through the Mission Control Center. And it also turned out that we had a number of Japanese flight controllers here in town. And so the plan immediately was to go utilize those folks to stop all significant or major operations in those modules and with the HTV, and use the Japanese controllers that were here to monitor and send commands to that vehicle. Even without the Japanese controllers, we'd have the capability to at least safe the vehicles here with the U.S. controllers. So we actually have plans for Houston. Of course, hurricanes is a major issue. We actually have capability, significant capability, which we've used on a number of occasions to be able to monitor and command the ISS. If you remember, during Hurricane Ike, while we were still, the population here was still fighting to recover from that, we actually docked a Progress vehicle. So there is capability. We built the capability around the types of natural disasters I guess you would expect in the various places. So we have capability here to handle, or capability actually through Marshall to handle ISS from the USS standpoint, for a USOS standpoint, and capability here to handle events here both in Europe and in Japan. So there's some capability. Obviously, it's not operations as normal, so we can't, we won't do complex operations. A lot of things require engineering analysis behind those operations, and of course the engineering workforce is disrupted as well. So we'll try to minimize significant complex operations on those segments while we're down. But Japanese were fantastic. They, not only in the midst of course, recovering personally and their families and the environment around them, they were very concerned about getting their control center back and operating, and they did that. So I'm very, very impressed with their ability to do that so quickly.
Philip Sloss with NASASpaceflight.com. I believe you had the 41P undock and the 42P dock had been on the calendar during the docked mission for ULF-6. How are you planning on deconflicting that with the mission?
So we're still in discussions with our Russian partners about that. We have a couple of plans. Some of the difficulties are there's a payload in the Progress that has a short time frame, and so the Russians are very interested in the time from when they, I'll say, initiate that payload, load it onto the Progress, and then get it on board ISS. So we're still working through the details about that. We have a plan to have the first part of the shuttle window where the shuttle would have priority. Then we'd stand down and let the Progress go, and then of course we'd have some window availability at the end of that for shuttle. But all that's still not finalized yet. We're still in negotiations with John and the shuttle program and with our Russians. I have no doubt that we'll work this out. It's just with all the traffic coming and going to ISS these days and all the constraints, we all need to sit down and work through this, and we're doing that. And it's really, and John will tell you the same thing, this is normal business now. Pretty much every time we get ready, we have various conflicts, and we all just sit down and work through them. So not a final answer yet, but we'll have it shortly.
Do you have any idea about the time frame for that? I mean, would that be towards the end of the shuttle flight readiness reviews, like the agency level FRR? Would it be in that time frame?
I would expect certainly by the FRR we'd have all that finalized, yes.
Bill Harwood, CBS, with one for each of you. But just to follow that up, Kirk, if the Russians can't deconflict the way you're looking at, I mean, what are the range of launch dates for the shuttle? I know the 19th is where you want to go. I know if there's no deconflict, it's the 29th. Where in that realm do you think you're going to end up when you say you're confident that it's going to get resolved?
So I'll let John talk about the shuttle window if you want.
Hey, we're targeting for the 19th, and we haven't done anything to say that we're not going to fly on the 19th. So,
there's a beta cutout in May, and there's a Soyuz. it's a significant window, though. We have a significant window, and like I said, I'm confident we'll work through that.
Okay. And one for John. It's a follow-up on Mark's workforce question. You guys recently had a fatality at the pad. Mm-hmm. I know you can't talk about that, obviously, with an investigation still underway, but can you talk to us in general terms about what you're doing or what the program's doing? I think you've told us this before, but just remind us of what you guys are doing to keep the focus on what you guys are up to as you ramp down amid layoffs and all the personal trauma people are running into.
Yeah, no, it was a very tragic event early last week. You're right. This is the investigation is underway. NASA Security, NASA Safety and Mission Assurance, the Inspector General, OSHA, the Brevard County Sheriff's Department, and the medical examiner have all been involved in the investigation. All I can tell you is, from an investigation standpoint, there's no evidence of any foul play, and OSHA concluded there was no fall protection safety issues involved in the incident. But until the medical examiner releases their findings, which we expect in a couple weeks, I can't talk any more about the details of it. As far as the team on the pad, obviously it's a teammate that has died, and we stood down for that day, talked to them, brought our employee assistance program counselors in to meet with the team and the managers. There was a strong desire to resume work on Tuesday by the team. We kept the counselors out there for the entire week, just in case anybody wanted to talk or any issues came up. And that, I think, was very effective. The senior United Space Alliance and NASA managers out there met with the team all throughout the week and reported back to me that they were very focused and very dedicated to completing the missions as we've laid out, and I agreed with that, and we resumed work. And we still have about 6 contingency days, so it didn't impact the ability to support our April 19th date. And when we know more about the investigation, we'll pass that on to you.
And I really wasn't trying to get you to talk about that. I really was looking more toward how you're maintaining focus all the way through the end here as you come into the home stretch.
Right.
With all the distractions on the workforce's mind. I mean it more in general terms.
Right.
And the second part of that is, what happens to you after the program ends?
Yeah. Well, we are, this is a unique team in my opinion. I've gotten probably every independent look there is out there from ASAP panels and NACs and standing review boards and things about how in the world are you going to keep this team together. And I tell you this, Linebach says it really well because he's out there with the ground processing team daily. But they're just a unique team that is this is more than a job to them. They are extremely passionate about what they do. They are totally dedicated to supporting the legacy of the shuttle program and finishing it right. And you see that every day. They just had a team building event out at KSC, and even the folks that are going to be leaving us in a couple weeks, they're very sad and upset that they're not able to see the program to the very end. It's much more, it's less about anxiety that there's an uncertain future ahead. They're more concerned about, hey, we want to make sure that the program is supported to the end correctly. And I can't say enough about the entire team, about how they've maintained their focus. We had some difficult issues preparing for the last launch with the external tank. The team came together. We actually even brought back team members that we had laid off previously, had them eschewed, and they returned happily and got us over the hump, and we were able to successfully fly that mission. It's so much fun to be a part of a group like this that is so passionate about what they do and really wants to preserve the legacy and do it right. And I just, every time we do any of these team building events, people end up, consoling me and telling me, hey, it's going to be okay, when I'm sad about them leaving the program. And I can't say enough about this team. As for me personally, I have no idea. That is not a focus of mine at all, just like it's not of the senior managers that I work with daily. We have the laser focus on these last two missions. We need to make sure we're really paying attention. We have done a lot of work on the contractor side and on the civil service side, making sure that we have, on the contractor side, the retention plans in place, and that there are workforce centers that are able to help them with resumes, with job placements. We've been doing a lot of job fairs, things like that. On the civil service side, we're going to retain all of the NASA employees, and just about 100% of the NASA employees are working dual roles, where they're spending time in engineering organizations, doing other jobs in operations and space and life sciences, where they have started to do some part-time work to build that relationship so that when the program ends, they can make a seamless transition to their new job. But that's not really true for the senior leadership. I want us to just stay focused on our main task, and that's to fly these last two flights out successfully.
Hi, Robert Perlman with CollectSpace.com with two questions for Kirk. John mentioned that Discovery's flight completed the ISS. So when other than AMS, but if additional Russian modules are added, if commercial modules are sometimes added, or if you are looking at any additional U.S. modules, like an additional node, are those viewed as bonus pieces at this point? And are you looking at any additional future U.S. additions to the station?
And we completed my piece.
Yeah. So if I come up with a few more pieces, then we can have the shuttle hang around and help us. Actually, one of the beauties of having a space station, and certainly the space station that we've built, is that it has the ability to expand and change. You've seen already the capability to move modules and even truss elements, right? We launched the P6 truss and had it on the top of the space station, then we relocated it. We've had Node 2 was initially installed in one place, and we relocated it. We launched MPLMs to the nadir of Node 1 port, and now we launch them to the nadir of Node 2 port. In fact, we put one permanently on the nadir of Node 1. So yeah, there's certainly the capability to add more modules. It really depends on what's required. What does NASA and what does the country need to support its future endeavors in space? And so I think there is the potential for additional vehicles. We're talking about commercial crew transportation vehicles. Perhaps there's a chance for additional modules, or at least testing out of additional technologies to support human exploration beyond low Earth orbit on board the ISS. So there's nothing definitive now from a U.S. standpoint, but certainly we have the capability to support that, and it wouldn't surprise me at all in the future if it's a piece of a strategy to support exploration that we would do something additional on board ISS. As for the Russian segment, they are planning on launching an additional module next year. They're still working on the official launch date, so they'll have an additional module going up. And it's the same on their side as it is on ours. They have capability to launch additional modules. They have docking ports which they can extend. So we have the ability to evolve over time and adapt, and I hope that's what we'll do.
Thanks. And with regards to this upcoming flight, is the Soyuz flyabout on the table at all? Is there any discussions amongst the international partners to, even though you won't have all 5 visiting vehicles there, to at least get a family portrait of the vehicles that are there?
Yeah, we're evaluating it right now. No decision has been made. So it's just under discussion and under engineering evaluation at this time.
Gina Sinceri, ABC News for Kirk. Are you ever going to name the space station, or it will be nameless for the next 9 years? And if you are going to name it, how will that process work?
Expected that one.
Yeah. So
We talked about this a couple of years ago, that when it came to the end of construction, that he thought it would finally get a name. And I'm just curious, how that process would work?
That's something we haven't worked through at this point in time. So I don't know. I'll tell you, our last experience with naming something in a public forum ended in an unexpected fashion. So I don't know that we'll let Colbert name the ISS, but But so we'll talk about that. I don't know how we would do that, and we don't have any concrete plans to do that at this time. But clearly, some vehicle that lasts as long as ISS lasts it deserves a name. So we'll certainly talk about that. And if you want to name it, we'll talk with you here when we get ready.
Take up on that. Okay.
Eric.
Hi, I'm Eric Berger with the Houston Chronicle. A question for John. Can you talk a little bit about the confidence you have that the 135 is going to fly? It seems like it's all but official now.
Yeah, no, our direction from NASA headquarters was to not take any personnel actions that would preclude the ability to go fly 135, which essentially says that you're going to go fly it because we would be taking workforce actions to issue warn notices and things like that. A few weeks ago, actually, if we were not going to go fly it. It looks like the budget is lined up to support that mission. Atlantis is being processed. We're stacking solid rocket boosters, and from a program standpoint, it looks like we're going to go fly that mission, and that's certainly the attitude of the team.
Irene.
Can you move to the side? Hi, Irene Klotz with Reuters. I have a couple of questions for Kirk. Could you give us just a little status on where things stand with the process to hire a nonprofit to become a partner in the station program, and also while you're thinking about that or answering that on a bigger picture perspective with the shuttle program ending? And I know you've been operating station for quite some time now, but there's a very big transition to kind of move into space operations on the station without having the shuttle launch component being a big part of, what NASA does on a day-to-day basis. Just what do you see are the, challenges coming up as you move out into kind of full-time operations without the shuttle?
Okay. First on the Institute to run the national lab portion of the ISS, we have a procurement out for what I call a non-governmental organization to go organize the payloads to fly under our national laboratory capability, and that's ongoing. So we're just out trying to procure or get an organization started to go support that. So I don't really have much more than that at this point in time. That is definitely our plan, and we're actively off doing that to have this organization out there to support prioritizing the payloads that would fly under the National Lab capability on board ISS. As far as transition of ISS to operate without shuttle, it's going to be very difficult. ISS was designed, certainly built with the shuttle, and we really, it wouldn't be possible to build something of this magnitude without a great vehicle like the space shuttles to go assemble it, carry it up, and also it's not only carrying cargo, both pressurized and unpressurized cargo. It's really all the people involved. So when a shuttle flies, you get the cargo, which is great, which is required, but you also get a whole bunch of extra hands to go help assemble it, people who are trained specifically for those tasks to go execute them and to handle any contingencies, and very, very efficiently. And then once all the planned work is done, even to do, I'll say, some unplanned work. If you saw on the last flight, STS-133, we finished all the planned objectives of the mission, and yet there's still lots of work to be done on the shuttle, on the ISS. And so we said, hey, let's stay for an extra couple days and put those people to work in helping us organize the ISS to be more efficient, allow more crew time to be available to support research. So huge benefits we get from the Space Shuttle program, and of course we've been great partners for many, many years. So it's going to be difficult. As you know, we have commercial capabilities under contract now to support the logistics in terms of flying cargo to ISS. Those guys are progressing towards being able to fly up and deliver cargo to the ISS. They're not ready yet, And that's why STS-135 is really important to us. It's going to put us in a really good position to allow us some flexibility in those commercial providers slip into the right if that's what eventually happens. That'll help us from a cargo standpoint. That'll be a big transition. Certainly we need some margin or flexibility to allow those guys to fly when they're ready to fly. And again, shuttle's going to help us do that. And there really is no replacement for all the extra hands that we get, and the highly trained spacewalks that we've had the benefit of having with the space shuttle. So we're going to be a little less efficient on our spacewalks, and things are going to take a little longer on board ISS without shuttle. That has been our plan for a number of years, and so we'll deal with that. But it's it's a sad day for us as well. Shuttle has been an outstanding part of the International Space Station, and we wouldn't have an International Space Station without shuttle. So it'll be a big step for us.
And for John, you mentioned, and you've mentioned many times over the past few years about this shuttle team and how unique it is to be able to pull this off. And I know you've been in government side of the house for quite some time, but is there anything that you can identify as specific to being in a government agency that precludes this sort of teamwork in a private sector realm, such as what NASA hopes to be transitioning to with new launch providers?
Yeah, that's a great question. It's interesting, Irene. What I expect is after the space shuttle program ends, that these people with the passion for spaceflight will seed out into other companies that are doing the commercial cargo activities and the commercial crew activities, and will take that experience and corporate knowledge that they gained in how to do spaceflight operations with the shuttle program and transition that to the commercial sector. So I think that's going to be a big benefit to those companies that are doing that. And just kind of stepping back and looking at it, there's a lot of overhead associated with government space operations that you could be leaner. In looking at some of the commercial crew and cargo organizations, they're extremely lean, and they'll probably need to beef up a little more as they start to do crewed operations, and they'll go through that learning curve. So I think there's probably a very happy medium between the two ways we do operations, where the government is probably a little more burdensome than we need to be, and the commercial companies, as they get into crewed operations, are going to have to staff up a little bit more. And so that's going to be a very interesting transition. And I think that a lot of the people I work with on a day-to-day basis are going to be an integral part of making that happen. So I'm looking forward to seeing that occur.
Christina Bergmann, Deutsche Welle, German International Broadcasting. I have a question for both of you. You have an ESA astronaut on board this time. So how does the end of the shuttle program impact the cooperation between NASA and ESA? Thank you.
Actually, I don't think the end of the space shuttle program will impact the cooperation of NASA and ESA. We've been great partners in a number of endeavors prior to the space station, and certainly we're cooperating very closely on the space station. We know that ESA here just I think a week or two ago finally had their approval to support ISS through 2020. So I expect that cooperation to go through 2020 on board ISS. I know we're cooperating on a number of other endeavors outside of ISS, and I really expect that we'll cooperate for human exploration beyond those endeavors. So I think we'll continue. The thing that's going to happen is we're going to fly less humans to space. Without the shuttle, we're going to fly less humans to space. So in the future, there are going to be less ESA astronauts. There are going to be less U.S. astronauts. There'll be less astronauts, people in general, who will be flying to space. So I think that'll be the only change. John?
Can't say any better than that. That's right.
Global competition of going into space. What are your feelings towards that? Other countries starting a race to space, so to say.
Yeah, other countries have their own national interests. Certainly, we respect that. There's been discussions, I know, in ESA about potentially flying, having a capability to fly humans into space. Certainly China is doing that. I would like to see us cooperate on endeavors to go beyond low Earth orbit. And really the only way we'll ever be able to afford that, I think, globally, is to have people build separate pieces and not everybody build the same piece. That's my personal opinion. But so it's to be discussed in the future. Certainly if ESA or Germany would like to do that on their own, we'd certainly respect that and understand that.
Come over here, Marcia.
Marcia Dunn, Associated Press for Kirk. Is there still any desire or movement in the space station team to try to push 135 to the right so that you would have a little bit more gap between the last two flights?
We're ready to support STS-135 when the shuttle's ready to go. So the concern on our part has been having enough cargo, both food and those kinds of supplies, as well as spare hardware that we need to support flexibility for these commercial providers to come up later. We'll have that if it flies in late June, and we'll be ready to go. If it flies later, that would be okay as well. But we'll be ready in late June, and it won't be an issue at all. So there's no great push. Like I said, we're ready to go when it's the right time for the shuttle program and when it's the right time for the agency. We're ready to support that.
And I would add, Marcia, on that, from a shuttle program standpoint, we're pushing pretty hard to make that end of June date. And that's actually something of a challenge to us, since we've added the requirement for the tanking test for that external tank, and to do some x-rays on the pad after that. That added a lot of time in the flow, and so we've actually ramped up and are contemplating moving Atlantis to the VAB about a week early to let us get out to the pad so that we can accomplish all that work. So we're actually working some overtime to support the June 28th opportunity, and I would expect that after we launch Endeavour in mid-April, then we'll look at the launch date and see if we need to add a couple days to the flow, or if we're still good for the 28th. But we have a big push on to make that date.
And you mentioned the tanking test x-rays on the pad. What's all that about?
It's just the same thing that we did on the last flight. We've done the modification to the external tank to add the additional brackets. We'll tank it out on the pad, go and do the x-rays, just verify that everything's in good shape. Yeah.
And lastly, John, you mentioned in response to Bill's question, you were regarding the worker tragedy at the pad. I know you said no foul play. What was the second thing you said, that there were no protective devices failed? I'm not quite sure I caught what you...
Well, sure. Anytime you have a workplace issue like that, you have OSHA comes out and make sure that you're okay before you resume operations. And they, I think the right terminology is that there was no fall protection safety issues. There were no tether issues, or yeah.
Jim Oberg with NBC. First question for Kirk. Can you review for us the current status of the ISS life support systems and work going on with them, and then comment in general on what this is teaching us about building the next generation life support systems for missions beyond low Earth orbit? Sure.
That's a long status, but I'll just say in general, everything's working right now. We have a number of issues that we're working through, but all of the life support systems are operational. We just did a activity earlier this week on our water processing assembly, which is basically the rack that takes condensate water, basically water that we collect from our air conditioning system, and actually it takes the processed urine from our urine processor assembly, purifies it and makes it available for crew consumption and or use by our oxygen generation system on the U.S. side. So it's all functioning. We have a number of issues, though, things that we learned while we're up on space station. One of the ones, the pH becoming more acidic in our oxygen generation system. The growth and the way it grows of biofilms in some of our racks, water processing racks. All those kinds of things we're learning as we go. There's a significant supply chain that's required on ISS to support our urine processor and other regen racks. And those kinds of things we won't be able to live with for a flight beyond low Earth orbit. We won't have a long resupply chain, and we won't have the ability to go fly up something new because we've discovered something about the way the system operates. And that's what we're really learning on ISS. So we are actively modifying our systems as we learn more, not only to deal with issues that come up that you learn when a system operates for years on board a space station, as it would perhaps on a vehicle going to Mars, but also finding out new and clever ways to reduce the supply chain that's required, figuring out ways to do all that on orbit as opposed to having to fly new filters or new equipment. And that's invaluable. I think that's really something that the space station offers a great opportunity for, both in terms of ECLSS, but really in terms of all space systems, and required to keep a spacecraft and humans alive for a long time out in that environment.
Thank you. That's excellent. I'd like to ask a what-if question for John and you, because we live in a world of uncertainty, and if the time came and if the Congress got its mind to it that all of a sudden 135 was not there, you'd be faced with some significant issues in terms of deciding what to do with 134, including major changes, or in fact going to 135 directly. Do you have any choice as to which of the two payloads you'd have to, which of the two children you'd have to kill in order, if you only had one launch?
I'll give you my perspective, and I think Kirk would agree, is that we would not make any significant changes to 134. Its cargo has been thought out very well. Matter of fact, it was going to be the next to last mission, and 133 was going to be the last mission for a while. It's been said many times what 135 provides you is margin to keep 6 crew on ISS, to have them doing useful work. We fully expect that the commercial cargo companies are going to be able to fill some of the logistic supply requirements of the ISS that the shuttle currently does. But it's flying 135 almost gives you an extra year of logistics that you can use to keep 6 crew up there until the commercial cargo guys are able to stand up their operations on a regular basis. So that's what you're providing on 135. So I don't know, Kirk, if you have any changes to it.
I absolutely agree. John said it right. We've organized the flights, the sequence in our priority, and so we would just stop. We wouldn't be any significant changes. There might be 1 or 2 things we'd want to swap out on the mid-deck, and I don't even know what those are. Right? We'd want to talk about that. Certainly, ask our workforce about that. But I would expect very, very few changes. But we'd have significantly less margin on board ISS. We would be really requiring these commercial cargo providers to step up and meet their dates. And if we didn't, we'd be reducing crew size and taking risk with a multi-billion-dollar asset. So
but you're not losing any sleep over this. You're not losing any sleep.
I lose sleep over a lot of things, but this is not one of them. No.
Hi, Clara Moskowitz with Space.com, and a question for both of you, if you wouldn't mind. You mentioned we're coming up on the anniversary of both the shuttle program and the 50th anniversary of human spaceflight, and I was just hoping you could both comment on how far we've come in the 50 years since humans have been flying in space, and how far we might get in the next 50 years.
Well, I was talking to a coworker yesterday, and if you just look at STS-134, it is an extremely complex mission. It's a long period of time up docked to the station, 4 EVAs, a tremendous amount of activity internal to the ISS. We're going to put a world-class experiment on the ISS and get it all hooked up. Even when we depart the space station, we're going to back off and then do a rendezvous with all the sensor systems that we would use on an Orion capsule to replicate that and make sure they're sensor systems. So we'll use the shuttle as a test bed for that. It's a tremendously complex mission. And when I look at our ability to pull these missions off flawlessly, our ability to assemble large structures like the station with really no significant issues, to get over the tremendous number of EVAs that was required to do the station. I think that the missions that we are executing now in complexity are the most difficult missions that not just NASA, but any nation has ever flown in space. And I would include Apollo in that discussion. I think the missions we do right now are more complicated than what we were doing back, even when we were doing the moon landings. And that is just it's the slow progression of you learn how to operate in space. You learn how to do things. You learn how to do spacewalks. You learn how systems work. We brought Discovery back earlier this month, and it was the cleanest vehicle, not just from a thermal protection system standpoint, but from a vehicle system standpoint, from an operations standpoint of what we did on orbit. It was absolutely clean, and there was zero wrong with that vehicle, and that's exactly the point we want to be to as we're ending the program. We want to have the cleanest missions we've ever flown, and you just have to do it, right? It takes time, it takes repeated missions, you learn from that experience and you move on. And I think we're poised right now to take this experience and roll it into whatever the next program is. And it may not be a NASA program, it may be a commercial crew program, maybe a commercial cargo program. I think that again, shutting the shuttle down, while it is painful, we're going out exactly like we wanted to, on a very high note, successfully performing the most complex missions, leaving ISS in great shape, and then we're going to take all this experience out and go do new things with it. And it's, as Jim said, there's a lot of uncertainty out there right now. There won't always be uncertainty. We'll have very clear direction, and I expect that we will free up this magnificent team to go and execute those new programs and projects and be very successful at it. So, you got to kind of take a look at the long view here. Is that we've learned a lot. We're at a great point. We're going to stop doing what we're doing right now from a shuttle standpoint, and we're going to re-vector that team into other activities. And I couldn't be more confident in this team's ability to go and execute amazing things. Yeah.
Yeah. Well, so it's 50 years ago, Yuri Gagarin got in a rocket and to go into space and didn't know if he would survive, didn't know if humans could survive. We had flown some other mammals, but no humans. And then you look at where we are today. So today we fly up to space. There's certainly a risk involved. It's a very complicated business, but almost 300 people have flown up to the International Space Station. The world of spaceflight has really changed dramatically. We have people who've lived on board ISS for 10 years. So kids who are getting almost finished with elementary school have never known a time in their life when humans weren't living in space. So the world's a significantly different place. 50 years ago, you didn't turn on the TV and look at weather satellites and figure out when a hurricane's going to hit Florida or North Carolina or Texas, and today you get on your laptop sitting in a press conference and look at what the weather's going to be like anywhere in the world. And so tremendous changes since Gagarin has flown. And the space shuttle, really, if you look at how far humans have progressed in space flight, the shuttle was probably the single biggest thing that's ever occurred in terms of bringing us forward. And so the shuttle was a huge part of that and continues to be. So I think both events, it's great that they're on the same day and very, very momentous occasions in the progression of humankind. So looking forward to celebrating those events and looking back not only as the Russians and the U.S., but really as a world community on those both vehicles and people and how they've meant such things not only to our respective countries, but really to the world.
Right there.
Hi, I'm Mike Cronin from The Daily, and this is a question for Mr. Shireman. I'm interested in how the transition is going to take place now that the shuttle won't be going to the ISS, so the public's perspective will change. It won't be the news of the shuttle launching or landing. Instead, it will be whatever science perhaps comes out of the ISS. And what are NASA's plans specifically to better publicize that science? And do you have some experiments that you could specify now that would give the public some examples, whether there are human effects or space effects on humans living in space, or materials that the person on the street could say, oh, okay, that makes sense, that we're going to have the space station continue for the next 8 years?
Well, let's see. Certainly, when you launch and land people, it's very exciting, right? There's smoke and fire and lots of noise, and it's really an inspirational thing. I don't know if you've ever seen a shuttle flight, for instance, but it's not only a physical thing; it's really an emotional thing. So it's a tremendous, exciting thing, and that's why it shows up on the news when we launch. When you're on board the space station every day, you're working on experiments which are very important, certainly to the research community, but really could be very important to a large population. But the experiment itself takes time. And in fact, a lot of times it's a year or two after you complete the experiment before the results actually get published. And in some cases, they're scientific things that take another period of time before they're applied. So there's a long lag between you do the experiment and when you actually see, hey, this affected my life. And so, yeah, it's not a hey, tonight on the news we did this experiment and learned this. It's not an immediate phenomenon. So that's one of our challenges. There's lots of things that go on board ISS that are really exciting, and we try to publicize those. We're looking at a number of avenues. Both we have the NASA channels. We're using more social media today. You get tweets. I don't know if you do, but you get tweets from the crew that's living on board ISS. That's a really interesting way to stay connected to what's going on. We have Twitter accounts where we publicize the research that's going on board ISS. So every day, 2 or 3 times, you get a message about what's going on ISS. So we're trying to connect with people the way they relate to the world today. So we're going through written media, we're going through TV, we're going through the web, we're going through YouTube, we're going through Twitter, we're going through all these types of methods, and we're going to continue to evolve to try to get that message out. But the bottom line is, it's never going to be as exciting as when you see a shuttle launch, or you hear the sonic booms when a shuttle is flying over Orlando on its way into KSC. So we'll look at other ways to try to connect. When we have research results, we're doing our best to announce those and publish those, not only in the scientific media, but also in the global media for folks to understand exactly what that might mean, without necessarily understanding all the technical details of that research. And if you have ideas, by the way, we're looking for great ideas. So we're doing our best, but we certainly need help. So if you have ideas, we'd certainly be interested in them.
Well, I think that actually if you did have some scientific results, it could be even more exciting than the shuttle blasting off or landing. That's been going on for 30 years. So if you have a scientific experiment that shows the effects on the blood or the thinking or the brain of a human in space, or a virus, or something like that the general public could learn about, that would be astonishing. So that's what I'm looking for. Do you have anything going on right now, or that's planned in the next few years? This is what we're going to look at, and we want to let all of you know about it, because this is what we are examining, and this is what could occur as a result.
Sure, I understand your question. We're looking at all kinds of things. A lot of the research that we're doing are research on humans as relating to living in a zero-gravity environment that would support long-term humans' presence in space. So traveling to Mars, things like that. So we're doing a lot of research on that. We're doing research. We've had some research on microencapsulation, which might be really important to delivery of drugs that would be targeted for specific areas of the body or maybe tumors. That's been done and continues to be researched. That has promise to do significant things, but there's no. It's not a hey, this is a cure for this disease, but very promising results. We've done experiments on board the shuttle and ISS that show that viruses and bacteria can be more virulent in a zero-G environment, which is leading to how you might vaccinate against those things. And there's been a number of those. One of them has to do with salmonella, and they're also looking at some other bacteria, that disease-causing bacteria, and how you might create a vaccine as a result of what you learned from how these bacteria and viruses behave in space. Dr. Ting and his group is launching AMS, which has the potential to look at basically understanding of our universe and how it was created. So huge potential for results, at least understanding where we came from. So I think there are a number of things out there. I can't give you, hey, we solved this unsolved problem, and it's going to affect every person's life at this point in time. We are definitely optimistic that we might get something like that, but in the meantime, we're making significant advances in quite a broad range of areas. We're doing a capillary flow experiment that looked at bubbles and how they affect the flow of liquids, which has effects not only on human beings, but also maybe in terms of decompression sickness, but also has importance for the future space vehicles, not only human but unmanned vehicles, and how propellant or liquids might behave better in that environment. So you improve engine performance, improve cooling, all those kinds of things. Those are experiments that are going on board ISS as we speak. So quite a number of things that are going on. Just not a great earth-shattering finding just yet, and we're looking forward to that day coming. Mm-hmm.
Okay, let's go down to Florida to the Kennedy Space Center for a couple of questions.
This is Todd Halverson of Florida Today with a couple, if I could. First for John, I'm wondering if you could remind us of the pedigree of this external tank on STS-134. I seem to remember that this one might have been damaged in Katrina, and if you could just remind us of the pedigree and tell us why you think it's safe to fly.
Yes, this external tank 122 was in one of our production cells down at Michoud when Hurricane Katrina hit, and several small chunks of concrete were dislodged from the roof and glanced off the tank, damaging the foam. We kind of put that tank to the side for a while we were doing normal processing. I asked the team several years ago to go back and look at ET-122 and see if it was a viable flight tank. All the foam in that area was dissected. The LOX tank, they did eddy current, they did all kinds of non-destructive analysis on it. It's a very good tank, so they replaced that foam. They went to the inner tank area. There was one stringer that had been nicked, so they took that stringer off, put a new one on, refoamed that area. They did testing because the TPS, or the foam that's on ET-122, is almost 10 years old. So they did pull tests all over the tank and did assessments to make sure that it's a good tank and safe to fly. Then they did all of the return to flight modifications that we had done on tanks after Columbia to 122. They did things like taking the flange apart, reversing bolts, injecting foam, cutting off leak paths where you could get cryo pumping and release foam. All of that work was done on ET-122. We were not, since it was an older tank, when we talked about doing the LOX inner tank stringer fix that we did on the last flight, we didn't have sufficient metal material to determine whether those stringers were of the lower fracture toughness that we've seen recently. So we went ahead and put that modification all the way around the LOX flange. However, in doing that modification, you have to drill out all the stringers to make sure you can put a new fastener in. And the guys out at Marshall took the shavings from those drill out areas and mounted them, polished them, took a look at them under scanning electron microscope, and determined that the material crystal structure, the metal structure, was of a very good lot of the stringers. We do not have the issue that we had with the last flight or the last tank, and the metal is of the normal fracture toughness. Even though we had that modification on there, we went ahead and put it on before we knew that. In the process of doing that modification, we understood that actually we didn't need to do that. So we went and made sure we did all the testing that the modification would work with the normal fracture toughness material. And that was good results. So we have a lot of confidence in ET-122. It doesn't look real pretty because we did some foam patches. It looks a little more like the hail damaged tank that we flew, which I think was ET-120. But it's from all of our testing and all of our experience, we have high confidence in that tank.
Follow for John, and I have a couple for Kirk too. John, I was just wondering, as manager of the shuttle program, where you think the orbiters should roost in retirement.
Totally focused on the operational life of the vehicles, and once we land and we mark where they land at whatever landing strip we go to, I walk away, and then it's somebody else's issue. You know, Dorothy is actively working the disposition of the assets and getting the vehicles prepared. I understand that General Bolden is going to announce on April 12th where the orbiters will go, and at that time we'll start working with those museums to understand their requirements and transportation requirements, and they'll have a good understanding of how we're going to safe the vehicles before they get to their respective places. But I haven't been involved at all in the discussions, and I am very happy for that.
Thanks. And for Kirk, I'm wondering if you can compare or maybe this is John too, compare the upmass capacity on STS-135 to a X number of Progress cargo carrier flights to the International Space Station. I'm trying to get a good handle on exactly how much more you can get up on that particular flight.
Yeah. So I get you a better number based on the numbers that we have there, but I would say it's about 6 to 7 times in the MPLM itself, and then you have the middeck, which is probably another 3, so close to, I'd guess close to 9 times. But let me, I'll get you the exact number. But the thing I wanted to point out that's different about shuttle than it is from a Progress. Number one, you get the capability to bring up and in this case return unpressurized cargo. So our plan is on that flight is we're going to return a failed pump module. So we'll get to bring it home and look at it and understand why we had that failure. So we're also bringing up an unpressurized payload that we'll bring up, and we wouldn't be able to do that on a Progress vehicle. And then in addition, you have crew members, you have humans there that can do additional work for you. So we can do maintenance on ISS, we can do assembly on ISS, we can do cargo transfer and cargo packing. All those kinds of things we'll be able to do that shuttle allows us to do that are not available on a Progress. We even bring up significant amounts of water. We don't bring it up. It's a byproduct of the fuel cell operation. So all those things are unique about shuttle that a Progress wouldn't have directly.
Thanks. And I'm wondering what your thoughts are, Kirk, on the idea of combining SpaceX's COTS 2 and COTS 3 flights, the objectives of those two flights into a single flight, which would be the next one up there. I mean, that would involve berthing the Dragon spacecraft to your International Space Station, and I'm wondering if you guys are good to go on combining the objectives of those two flights.
Yeah, we're still under negotiations with SpaceX. When I say we, NASA is, ISS is certainly a part of that. Our C-3PO organization is part of that, so it has not been finally agreed to. We have requirements that their demo flight number 2 is going to achieve, and additional requirements that demo flight 3 was going to achieve. And so the discussion is really, can we achieve all those things in one flight and then come in and safely berth to the ISS? Not only do those demos, but also those objectives, but look at the results and make sure that that everything's operating as we'd like before it gets close to the humans on board ISS, and certainly the ISS, a very expensive asset as well. So we're under negotiations. It's certainly possible, and we hope to come to some agreement here in the very near term.
Thanks. And the last question from KSC for Kirk also. Now that the assembly of the USOS is complete, I'm wondering if you can give us a good idea of the habitable volume of the space station in a way that, my next door neighbor could relate to it. Thanks.
I apologize, Todd. I don't have a great. We've used the volume of a large house, but I don't have a great analogy for you right now. I'll tell you what. I'll work on that next time. Next time I'm here, I'll have a great analogy for you. The beauty of ISS is that it operates in space, and you can use the entire volume, not just the floor. The crews that come back, I had a chance to talk to Scott right after he landed, and he's talking about how big it is. And so it really is even with 6 people on board, it's quite roomy. So it is large, and I'll come up with a great analogy for you next time.
Okay, I think that's all from Todd. We got a time for just a few more here. I start with Mark again, Beth, and then we'll grab some others.
Okay, thank you, Mark Carreau for Aviation Week. I apologize. I think I might be dialing back to the very first part of the briefing, but some of the scheduling shows the progress launching and docking with the space station during the Endeavour mission. Can that happen, or does that get deconflicted at some point?
It will need to be deconflicted. We would not want to do that.
Thank you.
And Bill.
John, can you give us an update on decommissioning Discovery? And I guess I'm looking, you told us last time we talked about this was back in September, and you were talking about taking some components off for forensic studies and engineering studies, et cetera. Can you give us a better sense, since this museum announcement's coming up, what sort of things are going to stay on the orbiter for display, and what things are going to be replaced with mock-ups, like engines, I assume, and things like that?
Sure. Actually, that's been kind of a fun discussion to have. Right now, let me tell you where Discovery is. It's in OPF2. The forward RCS is being removed right now and sent to the hypergolic maintenance facility for safing. We're going to start removing the main engines next week, and we'll take the OMS pods off, also send them out to the hypergolic maintenance facility. Then it's going to be rolled over to the VAB, and we'll temp stow it over there for when Endeavour comes back. It'll go into OPF2, and Atlantis is out of OPF1. We'll bring Discovery into OPF1 and keep working on it. We want to display the vehicles as realistically as possible, right? But the thought that it's going to be a flyable orbiter is just not true. There's a lot of safety issues where you have toxic chemicals and things that we've got to take that plumbing off, and we're not going to replace that. We'll either safe it in place. If you can't safe it in place, you just remove it and don't have it there. The main engines are an extremely valuable asset, and I want to save all of our Block 2 SSMEs that we have We have a plan to store them in a purged, safe environment, along with all of the ground systems required to maintain them until we decide what to do with the next program. So what we did is we went and really searched the facilities for excess hardware that we could build up into some main engines, and we've been doing that here recently. So we'll have 9 engines we'll put into each of the vehicles that are older technology engines, but they're real nozzles that flew, they're real combustion chambers, real pumps. And so we'll take out the really good engines that we'd like to save for the next program. We'll put in rebuilt engines that we kind of scrapped together, and that is what will be displayed. I'm also trying to find enough funds and enough parts to build some static engines that we can display with those vehicles as well, so people can see how big and how complex they really are. I'm also trying to save the OMS engines, the small orbital maneuvering system engines on the back. Same reason as if we can use them in a future program. I think they're very valuable assets. We don't have a lot of spares on those, so those are probably going to be mocked up and at least have a nozzle, but probably nothing behind it in the OMS pod. There are some things on the vehicles, especially Discovery, that we haven't looked at since it was built out in California, and things like actuators that it's very invasive to go in. I had some pretty good debates with the ground operations team about the difficulty of going to get some of these things, but from an engineering standpoint, this is a once in a lifetime opportunity to go see how a reusable vehicle actually how it weathered this many cycles, this many times on orbit, this much time in ground processing. So we'll go get representative actuators. We're going to get main engine flow liners, things that basically, you started with it and then you built the orbiter around it, right? So it's very invasive to go in and get them, but I really have asked the team to go in there and do that. And we'll send those out to our labs, and we'll get reports back. And I think it's, that's kind of the next legacy of the shuttle program, is to give you a lot of material knowledge, a lot of design knowledge in how things worked over a long period of time. And so, the vehicles, they're going to look very much like the vehicles that have operated in space. We're going to put on some hardware so we can save some of the higher value hardware. We're going to safe it so that the public's not exposed to anything dangerous. And we'll remove some things, but the public would never see, whether there's a left inboard elevon actuator or not, right? We'll put something else in there that'll keep the elevons at the right position, and then we'll go off and learn about it. But to me, it's more important to get that engineering knowledge out of these vehicles than it is to have total accuracy in a museum. Now, when General Bolden announces who is going to get the vehicles, we will go into negotiations, because I'm sure they will have an input into what they would like to have, and so we'll discuss our plans and the reasons behind them, and I'm sure there will be some negotiations there. But,
is Discovery the only one, though, you're planning that really invasive stuff on? Is it just the one orbiter, or are you hoping to do that on all 3?
No, we'll do it on all 3. Discovery, since it has more flight time, it's a little bit more of interest to us, but whenever you get engineering data like that, the bigger the pool of information you can get, the better your data is. So we'll do that on all 3. Matter of fact, I have my program requirements control board. We're going to review that today for Endeavour, and talk about the end state, what we're going to pull out, and what it's going to what we hope to accomplish from that. And the other thing that I have to kind of work around is it costs money, right? I have to keep the ground operations team and contractors and the experts in doing this around to do this work. And so I'm negotiating to get the money to be able to do that. So far, Bill Gerstenmaier and Nancy headquarters and the team really understand that this is a unique opportunity to get that engineering data, and they've fully supported it, but we're still working through that. Yeah.
We have time for 2 more. Go ahead.
Philip Sloss with NASASpaceflight.com for Mr. Shannon. For the 135 vehicle and the tanking test on that, are you planning on X-raying the backside of the inner tank for that vehicle? And if so, would that require a rollback?
If we were going to do that, it would require a rollback. That is not our plan right now. We have very high confidence that the repair will be very effective. So we'll do the tanking test. We'll X-ray the areas that are available to us on the orbiter side. If it all looks good, then we have sufficient flight rationale to go fly. Of course, if we find something, then yes, I would expect we would roll back and go through the whole thing that we did previously. Yeah.
Thanks. Irene Klotz with Reuters. John, how many main engines have you found to put into storage? And for Kirk, the 135 flight, does that carry the replacement for 1 or 2 COTS delivery missions?
Okay, the COTS question will be Kurt. For me, I have 14 right now, Block 2 engines, and we're actually looking at hardware to see if we could build up another 1 or 2 that would be available for future programs.
Yeah, and we don't look at it as a replacement for a specific number of COTS missions. What we're doing is we're launching a lot of consumables, launching some significant amount of food, and we're also launching a significant number of spares to keep our systems on orbit, in particular the environmental control and life support system. So we'll be able to last without a regular supply chain for a little while. So it's not, hey, this supplies exactly, I can last two COTS missions or 3 COTS missions. It's really building us margin to last about a year if we needed to. So in terms of what we expect from consumables, and then who knows exactly when those spares would be required. So it really puts us in a position to allow flexibility for these guys to learn and finish their development and be successful.
Do you have a list of that, like how much food, pounds,
I do, but not in my head. So if you'd like, certainly as we get closer, we can provide that. But I could tell you what we have the manifest right now about what spares we're launching and how much food and clothes and so forth.
Okay, that's all the time we have for this briefing, but stay tuned. At the bottom of the hour, you'll hear all about the alpha magnetic spectrometer. That starts at 9:30 Central, and then that's followed by a mission overview by the 2 flight directors that will oversee the mission from Mission Control. And then, of course, the spacewalk briefing, and then the crew in the afternoon. So a great series of briefings coming up on the details of the mission. So stay tuned to NASA TV for that. We'll thank everybody for coming.